Yet another way to solve quadratic equations is to use something called the quadratic formula. So we're going to look at ways that we'll use this to help us find when a graph of a quadratic crosses the x-axis. The quadratic formula is this equation that you see here, noting that there's a lot of letters again, which can make the math confusing. So let's describe what the a, b, and c are. My a value, remember our standard form of a quadratic, is ax squared plus bx plus c. So for example, if I had 3x squared minus 6x plus 2, all of these would give me my values for the a, b, and c that we're plugging in or substituting into this formula to find the solution, or the x value that makes the equation 0. Now, when we talk about a quadratic formula, or a quadratic, the graph, how many solutions can it have? We talked earlier in a previous lesson that a parabola can cross a graph twice and have two real roots, sometimes whole numbers, sometimes decimals. A quadratic could have one solution and maybe touch or hit the x-axis one time, and sometimes it can have no real roots and not cross the x-axis. So we'll see those types of solutions in our examples. When we first see our example 2, it gives us x squared minus 7 equals 4x. We want to get it in standard form. So if I have x squared and I subtract 4x from both sides, it'll bring my minus 4x and my minus 7 all to the left, and I have my equation. So we are looking for when this parabola hits the x-axis. Again, we could always graph it and see where it's hitting the x-axis to know where we're heading or to check. But let's use our quadratic formula first. Our a value is the number in front of x squared. In this case, it's a 1. Even though we don't see a number, it's assumed to be a 1 x squared. Our b is the negative 4. Don't forget the sign that goes with it, as the value in front of the x is a negative 4. And then c is negative 7. To follow our quadratic formula, we will start with our x equals. We want to think of this first part of the formula. It says negative b. Please note that that is not always a negative value. I like to think of it as the opposite of b. So I would have, instead of rb is negative 4, the opposite of that would be a positive 4. Then we continue with plus minus. Let's talk real quick why there are plus minuses here. Because we know that quadratics can have two solutions. So by having a plus option and a minus option, we'll find those possible two roots or zeros of the quadratic. So our equation says to take b squared. In this case, I'm going to take negative 4 squared minus 4 times a, which is 1, times c, which is negative 7. All of it divided by 2 times our a value, which is 1. Now, you can use Desmos to type these in if we need to. Lots of math errors can occur here, so you want to be very careful. We'll get to this later, but this value under the quadratic here, under the square root here is called the discriminant. Be real careful with your negatives. A negative times a negative is a positive. And we'll treat this as a negative 4 times a positive 7 is a 28. All of it divided by 2, which makes 4 plus or minus the square root of 44, all divided by 2. And at this point, we can use a calculator to help us estimate this. There is no square root of 44. One option is that x is going to be 4 plus the square root of 44, all over 2, or x is equal to 4 minus the square root of 44, all over 2. If we type this into a calculator over here, on a calculator like Desmos, you're able to carefully type in, just as you saw your solutions. So I did write this in the wrong area here, but we've got 4 plus the square root of 44 divided by 2. I'll circle my answer here, and you can see the calculator has calculated that for me, approximately 5.32. The other one that I typed with the minus sign was a negative 1.32. This means that the solution to our original equation, or when the quadratic that we moved over the minus 4x equals 0, means that quadratic crosses the x-axis at those two values. If I go to Desmos, I'm able to see, I typed in the quadratic when it was all on the left side, and I can verify that these x values are indeed where that quadratic is crossing the x-axis. We can always check with our graphs. So let's look at another example. If we have part B, or part A, let's do, for our number 2, we see that they're all on different sides here. So we want to get everything in standard form on the same side. I highly recommend that if you have an x squared, it would save you a little hassle if you leave it positive. So for this one, we're going to add 4x and subtract 21 from both sides. That will get us in standard form, and it'll still be equal to 0. X squared plus 4x minus 21 equals 0. My a value is a 1, so I'll put that here. My b value is a 4, and my c value is a negative 21. I would have to plug it into this quadratic formula again. So by substituting in my b and my a and c values and my a value again, I'm able to do the math, and when I solve this one, I actually get a square root of 100. This one feels a little bit nicer because we know the square root of 100 is 10. Keep in mind this plus or minus. This means that one solution is negative 4 plus 10, which would be 6 divided by 2, and that's 3. The other one is a negative 4 minus 10. And if we divide that by 2, we get negative 7. These would be the solutions of our quadratic equations. When doing the quadratic equation, the part that's under the square root, as I mentioned before, has a special meaning for when we're solving these. So the part that goes under the square root is b squared minus 4ac. I mentioned that we call that the discriminant, and here we see that vocabulary. It's called the discriminant because it will help us decide how many times that graph crosses the x-axis, or how many x-intercepts it has. Some might think of it as how many solutions that quadratic equation will have. If we find that your discriminant is greater than 0, there will be 2 real roots. That means the graph crosses the x-axis 2 times. If your discriminant is 0, it will have 1 real root. That means it would just touch the x-axis 1 time and turn around. If your discriminant is less than 0 or negative, it will have no real roots. So if we look at a couple examples down here, we don't have to do the whole quadratic equation. They just want to know how many solutions will each of these quadratics have. That is, how many times will the graph cross the x-axis. Completing the pattern of b squared minus 4ac, for each of these examples, we get 16 minus 12, which would be a 4, and we happen to know that there is a square root of 4. Since that's a positive number, we would say it has 2 real roots. The second one gets 16 minus 16 under that discriminant. Square root of 0 is 0, and they tell us when our discriminant is 0, we have 1 real root. That quadratic or parabola has 1 x-intercept, bounces off there, if you will. And finally, on part C, we have 16 minus 20, which is a negative 4. As previously discovered, the square root of a negative is not possible, so there are no real roots at all.